Hello and welcome to GED Mathematics Live at PALS. In this video, I will be talking about statistics and data analysis. What is statistics? Statistics is the science of studying and understanding data. While statistics is a huge field, questions on the GED test focus entirely on summarizing data, either by making certain calculation, such as finding the mean, or by creating charts, such as pie charts. Now let's proceed to analyzing data sets. The mean, median, and mode are all measures of the same thing. The measure of central tendency of a data set. The idea is that by describing the central tendency in a collection of data values, you can tell what the typical data value in that collection looks like. Which of the three measures best summarizes the data depends on the nature of the data itself. Let's start with the mean. The mean is the average of a data set. It is calculated by adding all of the values in the data set and dividing by the total number of values. For example, the mean of 18, 4, 2, 9, and 6 is 7.8. How did it happen? By adding all the data, 18 plus 4 plus 2 plus 9 plus 6, which is equals 39, and then dividing the total by the number of values, which is 5, we've got 7.8. The mean is affected by extreme values called outliers. Outliers are values that are much greater than or much smaller than most of the other values in the set. If a data set includes one or two outliers, then the mean is pulled toward those outliers and may not accurately represent the true center. Now, in the data shown on the screen, we can see the effect of changing one value in the data set to an outlier. Like data set 1, 3, 5, and 7, the mean is 4. However, by changing 7 into 70, an outlier, the mean increases to 19.75. In some data set, the same values appear numerous times. In such cases, when you are asked to calculate the mean, you may not be given a list of every individual value. Instead, you may be given the values and told the frequency of each one. Frequency, how many times it appears in the data set. When calculating a mean with frequencies, multiply each number by its frequency, add the results, and then divide by the total frequency. Let's look at that condition in an example. Jake has been playing a video game and has kept track of his scores. The following frequency table show his scores for the last 30 games. 1,200, 2 times. 1,800, 10 times. 2,000, 12 times. 3,000, 6 times. What was his average score for these 30 games? Okay, step 1. Multiply each value by its frequency and add the results. So we have 1,200 times 2 plus 1,800 times 10 plus 2,000 times 12 plus 3,000 times 6, and the total is 62,400. Step 2. Divide by the total frequency. So divide by the total number of values. The total number of values is 30, so the mean is 62,400 divided by 30, which give us 2,080. So that is the mean, and how to find the mean. Now let's continue with the median. The median is the middle value of a data set. When all of the numbers are listed in order from least to greatest or greatest to least, how it is calculated depends on how many values are in the data set. If there is an odd number of values in the data set, then to find the median, put all the values in order and select the middle value. If there is an even number of values in the data set, same thing, put all of the values in order and find the average of the two middle values. Let's look at some example. Okay, data set 1, add number of values because we have 2, 9, 12, 12, and 18. So there are 5 values. So the middle is 12. So the median is 12. Data set 2 shows an even number of values because there are 4, 6, 13, 15, and 20. Arranging them in order, we have 2 middle, 13 and 15. Then add 13 and 15 and divide them by 2. The median is 14. So basically 14 on the other hand is the average of 13 and 15. Now, considering the outliers, median is less affected by outliers. Looking at data set 2, the median would be 14 whether the last value is 20 or 200, because the two middle values would still be 13 and 15. Now let's check the mode. For some data set, such as the eye colors of students in a class, finding a mean or a median is not possible or doesn't make sense. This is even true for some numerical data sets. If you collected the zip code for everyone in your workplace, would it make sense to find an average? No. What would that represent? For data sets like this, the mode can be a way to measure the central tendency. And the mode is simply the most commonly occurring value. For example, in the data set 3, 3, 3, 1, 4, and 9, the mode is 3. If two different data values occur with the same frequency, both data values are modes. If all of the values in the data sets are different, it means the set does not have a mode. Now let's proceed to weighted averages. Okay? When more importance or weight is placed on certain numbers, in a calculation of the mean, you are finding what is called a weighted average. This is common in some grading schemes in which exams may count more than homework. A weighted average is calculated by multiplying each value by its weight and then adding the result. Let's see an example for us to clearly understand what is weighted averages. The final grade in a science course is determined by a student's performance on 2 exams, a final and quizzes. Each exam is worth 25% and the final is worth 30% and the quizzes is 20%. Given Sarah's grades, which follow, what will be her final grade in the course? Exam 1 is 85, exam 2 is 75, final exam is 72, quizzes is 80. So all we need to do is multiply each of the grade scores by the weight, by the respective weight. Okay, exam is multiplied by 0.25 or 25%, and 75 is also multiplied by 0.25 because it's exam, and 72 is multiplied by 0.30 because final exam is worth 30%, and 80 is multiplied by 0.20 because quizzes is 20%. Then adding all the answer, the final answer is 77.6. Now let's talk about the range. Okay, in statistics, there are many ways to measure the extent to which a data set is spread out. One of these measures is called the range. The range is calculated by taking the largest value in the data set and subtracting the smallest value. For example, the range for the data set 1, 9, 2, 5, and 7. So the highest value is, or the largest value is 9, and the smallest value is 1. So we have 9 minus 1 is equals to 8. So the range is 8. Now let's try some more example of analyzing data set. Okay, first one, at a certain summer camp, there are 10 9-year-olds, 6 12 years old, and 3 11-year-olds. What is the average age of the campers? Okay, the solution is 10 times 9, because there are 10 9-year-olds, plus 6 times 12, because there are 6 12 years old, plus 3 times 11, because there are 3 11-year-olds, which give us 195. Then dividing by the total number of campers, which is 19, the answer is 10.3. So the average age of the campers is 10.3. Now another one. Okay, use the following to answer question 2 to 4. The employees of the Marlac Community Hospital held a charity event to raise money. The following are the amounts raised by the 6 hospital departments that participated. Okay, the numbers are, or the amounts are $451, $690, $318, $500, $405, and $320. Now, using the informations, okay, let's answer the following questions. The first one is, what was the mean amount raised by the participants? So, to find the mean, add all the numbers, and then divided by the total numbers. So, we have 447.3. Now, what was the median amount raised by the departments? Arrange the data in order, then choose the middle, and the middle part is 428. Okay, the average of 405 and 451, because the middle numbers are 405 and 451, and the average of those two numbers is the median, which is 428. What was the range of the amounts raised by the departments? The answer is 372. It is by subtracting the highest number, which is 690, minus 18. So we've got 372 as the answer. Now let's proceed to summarizing data with pictures. The mean, median, and mode all represent specific numerical summaries of a data set. Graphical summaries, by contrast, are charts or graphs that are designed to give an overview of a whole data set. A statistician uses many different types of graphical summaries, and each has its own special features. Now, we will be looking into different types of charts and graphs commonly appear on the GED test. The first one is bar charts. Bar charts are a useful way to compare data for different categories. The categories might be numerical, such as the ages of different people, or non-numerical, such as different brands of automobiles. When working with bar charts, you need to pay close attention to the labels on the bars and also to the scaling on the horizontal or vertical axis. You will need to understand the scaling to answer questions. Now, the sample bar chart shows the total sale of a certain electronics company in 2012. Broken down by departments, the heights of the bars tells you the sales totals for each department. For example, the bar of the software department reaches a point midway between 20 and 30 on the scale shown on the vertical axis. Because the label says that the scale shows sales in thousands of dollars, the bar for the software indicates that sales by the software department totaled approximately $25,000. Note, now you can see at a glance that the hardware and training departments earned far more in sales than the software and support departments. Bar charts are a good way to illustrate contrast of this kind. The bars in bar charts can be horizontal instead of vertical. As you can see in the other bar charts, it illustrates the same data as the charts in the vertical bars. The only difference is that the bars are horizontal and the scale appears along the horizontal axis at the bottom. Now, let's see an example. Directions. The following bar chart shows the enrollment for a week-long seminar offered monthly to college juniors and seniors who are looking for jobs while in school. Use this information to answer questions 1 through 5. Okay, question number 1. In which month was a total enrollment the greatest? The answer is, by looking at the chart, is March. How many seniors were enrolled in February? Okay, how many seniors were enrolled in February? The answer is 40 seniors. Number 3, in which month did the number of seniors exceed the number of juniors enrolled? The answer is April. Number 4, what was the total enrollment in the seminar in April? So you just need to add the total number of seniors and the total number of juniors, which give us 135 in total. Number 5, in which month was the largest difference in the number of seniors and juniors enrolled? The answer is February. Now let's proceed to circle graphs. Circle graphs are also known as pie charts. These graphs use a circle to show how the parts of a whole relate to each other. The circle represents the whole. The size of each segment of the circle indicates the size of that category and the share of the whole that it represents. Now, looking on the screen, the graph shows the breakdown of expenses for a small business in July. Note that the size of each section of the circle corresponds to the size of the percent. For example, human resources accounted for 30% of expenses in July, so a section corresponding to 30% of the circle is labeled human resources. Note, don't forget that the total percents add up to 100. Now let's see an example. Suppose that the total expenses in July for A to Z used books were $14,780. Based on the graph, how much did the company spend on marketing during this month? So all we need to do is 0.12, that's because marketing is 12%, times 14,780, which is equals to $1,773.6. So the answer is, in July, $1,773.60 was spent on marketing. Now let's proceed to dot plots. Dot plots are very detailed graphs that can be used on a wide variety of data sets. On a dot plot, each individual data value is represented as a dot above a number line, and any repeated value is stacked on top of the others. This type of graph can be used to show how the data are spread out without losing any information about the individual data values. Now, the dot plot on the screen show the result of a survey in which a random sample of adults were asked how many internet-connected devices are owned by members of their household. Okay? Remember, each dot represents an individual response. Because there are two dots above zero, you know that two people stated that there are no internet-connected devices owned by members of their household. Similarly, only one person stated there were 10 such devices in his or her household. Let's try an example. Based on the preceding dot plot, how many people in the survey stated that members of their household owned more than 5 internet-connected devices? So, count the number of dots for responses 6, 7, 8, 9, 10 internet-connected devices, because the question says how many people in the survey stated that members of their household own more than 5 internet-connected devices. So let's add 3 for 6, 1 for 7, 8, 2 for 8, and 0 for 9. So we don't need to write 0, and 1 for 10. So adding all of them, 3 plus 1 plus 2 plus 1 is equals to 7. Now, let's see box plot. Okay, what is box plots? You know, box plots show a data set broken into 4 sections. These sections are based on the median and 2 new measures, the first quartile and the second quartile. These quartiles are defined as follows. Okay? If you will be given any data set, you can arrange it in order from the smallest to the largest in order to calculate the median. because the median is the middle value. Okay, the middle value. You can say that about 50% or half of the data set is smaller than the median, and about 50% or half of the data set is greater than the median. Okay? Now, the quartiles break these two halves into quarters. Okay? About 25% of the data values are smaller than the first quartile. So about 75% of the data values are smaller than the third quartile. So as shown on this screen, 25% for the first quartile, another 25% for the median, up to the middle, the second quartile, then another 25% added going to third quartile, and 25% is remaining for the data more than the third quartile. Along with the greatest and smallest data values, the quartiles and median are included in every box plot. The general shape is shown like this. Okay? Note that any very small or very large outlier are shown by stars or similar symbols. Okay, those are the outliers. Now, as with bar charts, you may see some box plots drawn horizontally. Either way, the basic structure remains the same. As your answer question about any box plot, remember that it is presenting the data in order, broken up into fourths or quarters. Now, the box plot on the screen shows the salaries in thousands of dollars for a full-time employees at a printing company. Now, using this plot, you can see that the smallest salary earned by any employee is $15,000, while the largest is $60,000. The box that covers the space from the first to the third quartile represents the middle 50% of the data. Okay, the box. So in this example, that means that 50% of the employees earn between $30,000 and $40,000 a year. So the median is $35,000, the line in the middle of the box. So you can also say that 50% of the employees earn less than $35,000 in salary. Okay, because 35 is the median. Now let's use the graph to complete the sentences. Okay? About 25% of the employee earn more than $40,000. About 75% of employees earn more than $30,000. Now let's proceed to histograms. At first, histogram seems not too different from bar graphs. However, the information contained in a histogram is much more detailed. Because histograms can be complicated, let's start by analyzing an example. Now, based on the histogram showing hourly wages, how many people were surveyed? And what percentage of them earn less than $14 per hour? Because the groups do not overlap and the height of the bar tells you how many people are in each group, add up the heights of all the bars. So we have 18 plus 10 plus another 10 plus 8 plus 2 and plus 4, which is equals to 52. So we've answered the first question that there were 52 people surveyed. Next is to find the percentage that earned less than $14 an hour. You need to add the frequencies of the bars that covers the range of values, the part, and divide by 52, the whole. So we have 18 plus 10 divided by 52 is equals to 0.538. So 53.8% of those surveyed earn less than $14 an hour. And now let's proceed to relationships between data sets. Line graphs and scatter plots are both used to illustrate relationships between two sets of data. In line graphs, one data set is the time when data values in the other set are occurring. In scatter plots, the two data sets can be anything. Both types of graphs are common on the GED test. Let's start with line graphs. Now, the table shown on the screen shows the sales that a company made each month last year. Looking at the table, it is clear that the company's best month was July. But what was the overall trend? Did sales fall in the winter? Did sales rise steadily throughout the year? Displaying this data in a line graph will help you answer those types of questions. In a line graph, the data is plotted against time, and lines are drawn connecting the data values so that the trends are easier to see as seen on the screen. So the sales data is plotted as shown on the screen. And now, let's try an example. The preceding line graph shows the monthly sale for a company last year. Based on this graph, between which 2 months did the company see the largest increase in sales? The largest increase? The one with the steepest slope, which is May and June. So the answer is May and June. And now let's continue with scatter plots. You know, a mechanic wants to know if there is a relationship between the age of a car and the typical repair bill at his shop. He finds the bills for 10 randomly selected cars that he has worked on. The following table shows the data he has collected. This is an example of a paired data. Each repair bill is paired with the age of the car. Data like this can be plotted on a scatter plot, just like points in the X and Y plane. For example, one bill was $200 on a 7-year-old car. If you plot each pair of data values in a similar way, we will have a scatter plot as shown on the screen. Now, when analyzing a scatter plot, look at the overall pattern. Now, if the point tends to locate along an imaginary line that rises from left to right, we say that there is a positive relationship between the two values. That is, as one value increases, so does the other. If the point tends to locate along an imaginary line that falls from left to right, we say that there is a negative relationship between the two values. That is, as one value rises, the other falls. Let's observe the following scatter plots. Okay, positive relationships. As one value increases, so does the other. Negative relationship. As one value rises and the other falls. Then we also have non-linear relationship, and when all the dots are scattered, then there is no relationship. Okay, let's check an example for line graph and scatter plot. Let's start with line graph. Okay, Casey is a runner and has kept track of her weekly mileage for the past 2 months. Use the following graph to answer questions 1 through 3. Question 1, in week 6, Casey twisted her ankle and had to run less the following week. How much did her mileage drop from week 6 to week 7? week 6 to week 7. So first, we just minus the miles run. 50 minus 10, so we have 40 miles. We have 40 miles. So Casey's mileage dropped 40 miles from week 6 to week 7. Number 2, during which week did Casey run more than 40 miles? So looking at the graph, we've got week 3 and week 3 to week 6. Okay? Because from week 3 to week 6, Casey ran more than 40 miles. Now, the third one, if Casey burns 110 calories for each mile she runs, how many calories did she burn running in week 2? So in week 2, there are 40. So all we need to do is 110 calories times 40. We've got 4,400 calories. Okay, another example for scatter plot. Caitlin, a middle school teacher, wants to see if her students' quiz scores graded from 0 to 30 are related to their exam scores graded from 0 to 100. She collected the following data from 8 students. Use this to answer questions 4 and 5. So 4, use the following scale to sketch a scatter plot of this data. So 5 and 65, 8 and 70, 22 and 88, 28 and 95, 30 and 90, 30 and 92, 17 and 95, 25 and 8. Based on the scatter plot sketched, which of the following statement is true for the student whose scores were included in the data set? So we have 4 choices. A, in general, students with higher quiz scores tend to have lower exam scores. In general, letter B, students with higher quiz scores tend to have higher exam scores. C, in general, there is no relationship between quiz scores and exam scores. D, there is a nonlinear relationship between quiz scores and exam scores. So the best answer is letter B. So that's the end of our video. If you have any questions or if you did not understand the parts of the presentation, you can comment below or you can contact us. If you want to know more about Phuket PALS, you can check www.phuketpals.org, or you can contact us through our Facebook, Phuket PALS, or you can call us or send us a message online on 081-417-0978.